Okay, so good morning. Today we're working on a different type of number that we can use to reflect the data set. What that means is we have a bunch of numbers, and how can I look at like the whole scope of numbers using some key elements? It's almost like these are characteristics of the data set. So I can look at these numbers and it give me a bigger picture without me having to look at every single number. And the mean absolute deviation, it's like three different things in one like statement, but it measures how much data set varies. What that means is how spread apart are the numbers. So let me show you a quick picture. Let me throw it up here. If you look at this picture of two kids playing basketball, Terry's basket, he shoots a basket and he scores 9 and 10 points a lot, versus Chris's baskets. And sometimes he scores 2 points per game. Sometimes it's 15 points per game. And what happens is, sure, like the averages might be the same, right? If I take the high score and low score, but in the end, which basketball player would you want on your team, right? Would you want Terry's or do you want Chris on your court, right? But on average, they're all about, about there. Right? If I take the lows and the highs, those cancel out to be something in the middle. So the average tells us about where our values lie, but the problem is that it doesn't tell us how spread apart our numbers are. And that's the thing about average. It's a simple number, it helps us get an idea, but it doesn't give us the whole picture. So we have a lot of different tools to look at different aspects of our data set without actually looking at every single number, because that would be daunting, especially if you have a data set of thousands of numbers. Okay, so we're gonna do this. It's really only two main steps, two big steps, and they literally are in the title. Okay, mean. So let's go and find the mean first. So I have a set of numbers, 8, 6, 9, 5, 6, and 5. So I'm gonna go ahead and add those up and divide by the number that we have. So we have 8 plus 6 plus 9 plus 5 plus 6 plus 5. And the idea is we're looking for the mean, right, which is the average. And sometimes we use the variable x bar to reflect that. And we divide by the number of terms that we have. 1, 2, 3, 4, 5, 6. I have 6 terms. Okay. So I'll need a calculator for this. So let's pull out a calculator. Of course, it's going to show me an ad. Whoops, of course, that was a trick. Is the x. No, there it is. Sorry about that. Okay, we're going to use our calculator. I want to add up all the points. 8 plus 6 plus 9 plus 5 plus 6 plus 5. I added the 6 numbers. Then we divide that by our value there. By 6. Oops, darn it. 8 plus 6 plus 9 plus 5 plus 6 plus 5. And we're going to divide that by 6. And that gave us a number 6.5. And that's not necessarily a pretty number, but that is the average. That's the value where if I took the highs, took the lows, and shared them amongst each other, they would all have about 6.5. Well, they would have 6.5. Okay? So that's the first part, find the mean. So we're going to call x bar, like a bar of chocolate, is 6.5. And now we're going to do the second part, which is called the absolute part. Now, our goal is to figure out, when it comes to mean absolute deviation, the word deviation is the important part of that. To deviate is to change. So our idea is how far are our values away from that average value here. Okay. So oftentimes when you guys get a test, you'll say, hey, what's the average? And then you'll tell yourself, oh, I was higher than the average, or I was lower than the average, or how far was I away from the average? Imagine if all the students did in the class, and then we could figure out in a simple number, how widespread are these numbers? How far are they away from the average? So it's the average absolute distance, you could say. So here's what we're going to do. Now that we found the average, we're going to compare all our numbers. How far is 8 from the average? How far is 6 from the average? How far is 9 from the average? Oops. And we don't care about if it's a high or a low number. And we're going to add them all up. 5 minus 6.5. That's going to be a little lower, right? And then plus 6 minus 6.5. And then we're going to say plus 5 minus 6.5. Okay? So our next goal is to add up all the differences. So let's go ahead and we do this with a calculator right now. But the first difference, looking here, look at the first difference. How far is 8 from 6.5? Well, that's going to be 1.5 away. And the absolute value makes everything positive, 1.5 away. Next value, 6 minus 6.5. How far is 6 away from the average? Well, it is negative 0.5 away. It's not that far away from the average. But because of the absolute value, that becomes a positive 0.5. Next one, 9 minus 6.5. How far is 9 from 6.5? That's going to be 2.5, a little farther, right? That's like the farthest value from the average. And we're going to make that into positive since it's positive rate, so we leave it alone. Next value plus 5 minus 6.5 gives me a negative 1.5. Okay. These are step by step. It's going to take us a little bit to work on these numbers. That's fine. You can get a calculator if you need to. Then we take the absolute value of that. That becomes a positive 1.5. Okay. If you notice, all the values here will be positive because we don't care if you're high or low. We just care for that number. How far are you away? What is that deviation? See, mean absolute deviation. We found the mean, and now we're looking for the absolute deviation. And then we actually come back to that mean part again. And then plus, let's go into the next value. That's going to be 6 minus 6.5. It's going to be a negative 0.5. And absolute value makes that a positive 0.5. And then plus one more number, absolute value of negative 1.5, because 5 minus 6.5 is 1.5. And that becomes a positive 1.5. Okay. Now that we've have these numbers here, you can take a calculator and add them all up because we're going to find out what is the average of these differences. So our last step here is let's go ahead and find this value here. 1.5 plus 0.5 is 2. 2 plus 2.5 is 4.5. 4.5 plus 1.5 is 6. 6 plus 0.5 is 6.5. 6.5 plus 1.5 is 7. Oh, whoops, I think it's 8. Go right add the 1. So this becomes the number 8. Now to find our mad value, our mean, let's write that nicer. Our mean, absolute deviation. We then take that and we divide it by the number of terms we had. We had 6 terms. And that's going to give us approximately 1.33. So what does 1.33 refer to? It says, sure, the average is 6.5. Average is 6.5. But how far are all the numbers away from 6.5? And the average deviation, average absolute, because we don't care if it's positive or negative, right or left, we just care that it's away from the average, is then 1.33. So on average, all the numbers are 1.33 away from the average. So why is this number important? Well, let's go back and look at our example with the basketball player, 2 basketball players. So if we look at these 2 players, they might have the same average. Okay? And if you go ahead and find the average is like 9.5. They would both have 9.5. So if I showed you two basketball players, one makes a bunch of baskets, they score pretty high, 9.5 per game, and the other one, Chris, 9.5 per game. But are they really both good basketball players? You know what? Terry's more consistent versus Chris. Chris has some awesome days, and sometimes he has some bad days. So if I'm looking for consistency, I need to figure out on average how far are his point scores away from his average, that 9.5 score. So if we look here and if we do the math, we'll see that Terry's mean absolute, his MAD score for Terry, MAD for Terry is actually 0.5 only. If we do the math, it's 0.5. If we look at the MAD for Chris, it's actually 3.75. Now, if I go and show you these stats, so not just for the 8 games we played, but imagine if these were all the scores he scored for the whole season. And you get a basketball player whose average point score is 9.5. That's a lot of baskets. Okay? He's contributing to the win. And his mean absolute deviation is only 0.5. That means he's almost always scoring 9.5. He's always around 9 and 10. See? The difference between 9.5 plus and minus 0.5, that means he's up to 10, 9.5, remember that? And you go plus 0.5 and a minus 0.5. So he's at 10 and 9. These are his scores normally. Because the deviation, the mean deviation isn't very far away. But if I look at Chris's basketball games, and his scores are really spread wide. And the mean absolute deviation shows, hey, it takes him sure, his mean is right here at 9.5, but then his scores widely vary by up to 3.75 points. So we can see like the numbers are not as bunched together, just with a simple number. So this is what we're working on today. We've come up with this number. So let's go back and talk about what are the steps. First, we're gonna find the mean because we have to compare it to what is everyone's mean. First step, find the mean. Second step, get mad, meaning we wanna find the absolute deviation. How far is everyone apart from each other? How far are you? If you have 6 numbers, you have to do 6 subtractions. Because we want to find out what each of these terms are away from the mean. Once we find that, we want to make sure they're all positive. That's important because we care about how far you are away from the average. We don't care that you're positive or negative on the right or left side of that. These values here are how far the numbers are away from the mean. And then we divide that by 6 to find that average deviation. So we need to be able to do these 2 main steps. First step, find the mean. Second, add up all the differences and then divide by the number to find the average difference, average deviation. Okay, so let's go and look at the IXL for today, what that looks like. Oops, not you guys. You guys are advertisement. So Algebra 1, all the way at the bottom, we're looking at the stats section. And we're looking at the mean absolute deviation. So a music student is cataloging some songs and noting the length of each. The 6 songs have a length of 5 minutes, 8 minutes, 3 minutes, 4 minutes, 2 minutes, and 2 minutes. What is the mean absolute deviation of song lengths? The answer is a decimal, round to nearest 10. Okay, so let's go ahead and come up with a place to work with. Okay, so our numbers are 5. Oops. So for mean absolute deviation, it's always done the same way. There's no tricks to it. You just add up the numbers. 5 plus 8 plus 3 plus 4 plus 2 plus 2, and we divide that by the 6 numbers we have, and that's our average. Okay? Because we want to compare all the numbers to the average. You can compare to any number you want, but for everyone to get the same number, we chose that as the average. So if we add that up, that's, let's use a calculator here. That'd be 5 plus 8 plus 3 plus 4 plus 2 plus 2. And we're going to divide that by 6. And we end up with the answer 4. So this is equal to 4. That's my average. So on average, all of the song lengths are about 4 minutes long. And then our second one is Get Mad. And that means we have to find the absolute deviation. How far is 5 away from 4? How far is 8 away from 4? How far is 3 away from 4? How far is 4 away from 4? How far is 2 away from 4? How far is 2 away from 4? So when we write that as, this is going to be absolute value of 1. 5 minus 4 is 1. 8 minus 4 is 4. 3 minus, so that's a, I don't know why I wrote a plus. Let me erase that. 3 minus 4 is a negative 1. Negative 1. So plus absolute value of negative 1. Plus the absolute value of 4 minus 4 is 0. 2 minus 4 is negative 2. And 2 minus 4 is negative 2. Now you could skip this step if you can do absolute values quickly. I'm just trying to show you guys all the work. The absolute value of 1 is 1 plus 4 plus negative becomes a positive 1 plus 0 plus 2 plus 2. You can add this all up. 1 plus 4 is 5, plus 1 is 6, plus 2 is 8, plus 2 is 10. So my average on top, when I add up all the deviations, all the changes, we end up with 10. And to find the MAD, the average, we take that number and divide it by 6. And we end up with 1.66. So approximately 1.66. And 1.66 is about, on average, how far all the other songs are away from our average of 4. Now, does this get harder? Well, I would say a little bit, because the numbers might get a little bit bigger, but the process is still exactly the same. Okay? Process is exactly the same. Okay. So that's how we find the mean absolute deviation.